Let's go through LeetCode 1062, greatest sum divisible by 3. It gives us integer nums, and we need to find a subset of these nums, which have the maximal possible sum of elements of the arrays, such as that it is divisible by 3. And we say that this num is positive. Actually, um, if it is not positive, we should still be doable. But the thing is that if it is a negative one, we should consider whether this one allow empty subarray. So we have two ways to do that. One uh, is using dynamic programming, and we use DP, right? So DP, which will be a multiple by 3. So what we do is that we have DPIJ, right? So will represent at index I, right? And J is the num mod by 3, right? So what is the maximal value so far? So in the end, what we want is to return DP um, n minus 1 0, right? So this is what we're thinking, right? And so for every number, we have two choices. We select this num into our subset, or we don't select. So if we select, right, select, let's say we don't select, so that dpi will be ij will be equals dpi minus 1 j, right? And also if we select, so we are going to have I minus 1. So dpi j will be dpi minus 1. So what will be this j, right? So we are going to plus nums I, something like this, right? So what will be this j? So if we select, its mod changed, right? So it will be j minus nums I multiplied by 3, right? Something like this. So this will be the transition function. Um, so in the every DPIT is coming from two states. One is do not select, another is select, right? So we need to get the maximum of these two values. Of course, the thing that this one will be negative, right? So in reality, what we do is that we should add 3 mod 3, right? And also our DP, we can have one more index so that we don't need to worry about the index 0. So this will be our, and also another thing is that so let's write code for this first. So we know we're going to have a private integer static INF equals the integer of the max value shift 1. Okay. So what we do is that int n equals nums of the length, and we have two-dimensional dp equals new int n plus 1 3, right? So we're going to have arrays fill for the in dp. We're going to have arrays fill d minus, because we want to have largest number. So let's set as minus IF, right? And we know dp 0, 0 equals 0, right? We do not select anything, so the sum is 0, and so and also the mod is 0, right? So for the others, it is minus IF. Then what we do is that for int I equals 1, I smaller than n plus 1, I plus plus. Then we're going to have int v equals nums I minus 1. And let's have r equals v mod 3. And for int j equals 0, j is smaller than 3, j plus plus. We're going to have bpi j equals max dot max. So we have a choice. Do not select current number, right? So that is I minus 1j. Or we select it. That will be coming from dpi minus 1. And this will be j minus r plus 3 mod 3. And then we're going to select it at v. So in the end, we just return dpn 0, right? So this is the dp way. And doing like this, it will be an O n multiplied by 3 time complexity. In the space will also be O n multiplied by 3 space complexity, right? But the thing is that we'll find the dp only rely on n minus 1, right? So actually, we can have a constant space. So what we do is that we can have this one as dp3, right? dp3. So we are going to have, we know dp0 will be 0. And we're going to have dp1 and dp2 will be minus IF. And dp2 equals minus IF, right? So for this one, we can have an int new dp equals new int 3, right? So we'll say new dpj will be dpj and dp this one, right? And in the end, we just have dp equals new dp. And in the end, what we want is just return p0, right? Um, so it's going to be O(n) time complexity with constant space complexity. And for this question, we have another way to do it. That is greedy way. So we know for the numbers, right? We can add those sums. So in the end, because they are all positive, no matter it is all positive or not, right? So I think because they are all positive, so the number when we add, it will going to be greater. I'll say the greedy way, possibly if there is a negative number, we cannot use a greedy way. Yeah, we can have to do using dp. So if there is a negative number, so if it is all of the numbers are positive, when we add that, the subset sum is going to be greater. So in the end, if we add these nums together, if the sum is mod 3 equals 0, then that will be sum, right? Then if it is the sum mod by 3 equals 1, that means we need to um, minus the minimal number in this, which has mod to be 1, or the sum of two number, which is minimal, we'll say the number which is mod by 3 equals 2, right? So we need to select two because this one, add this one, it will be the 2 plus 2 mod 3 equals 1, right? So we can minus the minimal number which mod by 3 equals 1, or the minimal number which mod by 3 equals 2, and the next to minimal uh, minimal by 2, right? So we need to find the minimum of these two, right? So the same thing, if the sum mod by 3 equals to 2, we can either minus the minimum value, which is mod by 3 equals 2, or the minimum value and then next to minimum value, which is mod by 3 equals 1, the sum, right? And then we need these two choices, find the minimal way, right? Greedy way, we'll say it's only apply this number are all positive. If it is there is negative values, then we'll have to use DP. So we can also write a greedy way to do this, right? Actually, we can still keep IF here. We can have the number mod by 3 equals 1, right? And this is the minimal value. And mod by 3 equals to 1, this is the second smallest. And mod by 3 equals to be 2, this is smallest. And this will be second smallest. And we'll have a result equals 0, right? So what to do is that for every v in nums, if v is smaller than, so let's have sum, right? Result added plus 2v, and also if v mod 3 equals 1, if v is smaller than the minimum O1, right? So then we'll have O2 equals O1 and O1 equals V. And else if V is smaller than O2, then we're going to have O2 equals V, right? So, and we'll write if V multiplied by 3 equals 2, then what we do is that if V is smaller than T1, then we're going to have T2 equals T1 and T1 equals V. And else if V is smaller than T2, then we're going to have T2 equals T1, right? V. So in the end, if result mod 3 equals 1, right? Our result should minus equal to this, the minimal value of O1 and T1 plus T2, right? And let's say if result mod 3 equals 2, then well, result should minus equal to max dot mean O1 plus O2 in the T1, right? So in the end, it's just a return result. So this is greedy way to do this. It will also be n-time complexity with constant space park complexity. So so this is the two way to do this, and we can also write a Python code for this. Um, so firstly, let's using DP. Okay. So we'll say DP equals 0 float minus um and this here will also be float IF. Then what we do is that for we in nums, we're going to have R equals V mod 3, right? So we're going to have new DP equals this one multiplied by 3. And for J in range 3, we're going to have new DP J equals max DP J. That is, we don't select, or we have DP J minus R mod by 3, right? By 3, and then we select current value. And we're going to have DP equals new DP. So in the end, we just return DP0. Or we can use a greedy. Greedy is very similar. We're going to have O1 and mod by 3 equals 1, right? The minimal and the second minimal. Mm, we want to find the minimal, right? So this is INF. So what to do is that we also need a total result, right? Result equals 0. So what we do is the for v in nums result to the plus equal to v. And let's say R equals v mod by 3. If R equals 1, so we'll say if v is smaller than O1, so we're going to have O2, O1 equals O1 and v. And let's say if this else if else else if v is smaller than O2, I'm going to have O2 equals v, right? So, well, right, if R equals 2, well, say if v is smaller than T1, so we're going to have T2, T1 equals T1 v, right? And else if v is smaller than T2, then we'll have T2 equals v, right? So in the end, what we do is that if result mod 3 equals 1, so we're going to have result to the minus equal to mean O1 T1 plus T2. And if result mod 3 equals 2, we'll have result minus equal to mean O1 plus O2 T1. So in the end, just a return result. this is T2.